On behalf of PwC India, I must thank Yogesh, Amit and team for organizing this event and bringing together professionals from energy, chemicals and other allied aspects. And like you would know, there are a number of scientific studies which say that to limit global temperature to 1.5 degree rise by 2050, you need two sources of energy to have a play. One, hydrogen with biogas, ethanol and other substitutes for oil and gas and coal on one hand, and the second is renewable electricity. From India's perspective, green hydrogen provides an option to not just mitigate the global warming but also help achieve energy security, like Amit just mentioned. Or as per some estimates, we could be a net exporter of energy sources, contrary to today's situation, where we are importing a third of our coal needs, more than half of our natural gas needs, and close to 90% of our oil requirements. In line with this thinking, Government of India, or more precisely MNRE, has announced National Green Hydrogen Policy earlier this year, and the target is to produce 5 million tons of green hydrogen by 2030. And a brief summary of policy I'll state before I request the panel members to introduce themselves. So the policy initiatives can be summarized into 5 aspects. 1, exemption of interstate transmission charges for large projects. Facilitation of open access and energy banking for green hydrogen and ammonium manufacturing. Third is renewable energy parks to facilitate equipment manufacturing and also manufacturing of hydrogen and green ammonia. Fourth, DISCOMs to supply renewable energy not at industrial tariff but at a cost plus basis with minimal margin. And finally, aggregation of demand by government agencies for economies of scale. The route that we have taken for LEDs, for solar and others. As you could infer, Government of India is keen to encourage green hydrogen to make green hydrogen a reality. Now, before getting onto the debate of sufficiency of these steps, I would request the possible esteemed panel members to introduce themselves. Maybe starting with Dr. Malhotra, please.
President of the Hydrogen Association of India, which we had formed about a decade back while I was the Director R&D of Indian Oil Corporation. Later on I was the Director General in the Federation of Indian Petroleum Industry. Now I am the Adjunct Professor of Practice at IIT Delhi, besides honorary work for the Hydrogen Association which I am doing.
Over to you, bro.
Good afternoon everyone. My name is Gautam. I work for Greenko. I'm leading the green hydrogen efforts there. I've been working for 20 odd years in the energy industry now. I did 21 years previously with Schlumberger in oil and gas, so kind of shift from grey to green for me coming to Greenko. So looking forward to this exciting energy transition in the next coming decades.
Ashwini.
Hi, good afternoon everyone. My name is Ashwini Kumar. I'm the editor of Fuel Cell India, India's first magazine exclusively for the hydrogen economy. By profession, I'm a lawyer, an environmental lawyer, and I've been working in the environmental space for almost 12 years now. And the magazine is an effort to bring intelligence and other developments in hydrogen within one space, so that it is easier for the public to understand the concept of green hydrogen and why green hydrogen is an essential fuel for the future.
Thanks, Ashwini. Maybe Debi, Prasad.
Till last 10 years, but today on green hydrogen instead of energy storage. The reason is that in the Indian market we see both storage and hydrogen will be complement to each other, because in many forums it is told that batteries or hydrogen. It is not like that. Both will be in the market. And in specific to green hydrogen, there are 3 basic needs in India. One is technology development for the reduction of cost of the electrolysis and transportation. Second is on the policy side. Maybe we are not all thumbs up to the hydrogen policy document which came earlier from MNRE. There is need of scope of improvement in the policy. And third one about market, because if you not develop the new companies in this space, then market will not develop.
Thanks, Debi.
Shardul. Everyone, my name is Shardul Kulkarni. I am representing Vibrant Energy. I am spearheading green hydrogen efforts at Vibrant. And last 21 years I have been working in the power and renewable energy. In the past, I worked with companies like SBI Cap, CRISIL, Tata Strategic, and I'm looking forward to a business disruption called green hydrogen. Very pleased.
So over to you, Deepak from...
I'm a program associate at CEEW. CEEW is the Council on Energy, Environment and Water, which is a not-for-profit public policy research institution based in New Delhi, India. So we have been very closely working with the government on developing the National Green Hydrogen Energy Mission. We are also working with various state governments to implement the Green Hydrogen Mission. And about me, I've been in this space at CEEW for 3 years. I primarily lead CEEW's research on green hydrogen, carbon capture and utilization and the iron and steel sector in India. Before this, I worked for about 5 years in the renewable energy space.
Thanks, Deepak. Thanks. Maybe to kickstart the discussion, in this space for close to 30 years, and in fact, you have spearheaded the pilot at IOCL for hydrogen manufacturing. Why do you think this is an opportune time for industry to focus on hydrogen and more so on green hydrogen?
I'll tell you about hydrogen story. In refineries, we are the largest consumers and producers of hydrogen, but we have been producing hydrogen from natural gas reforming mostly, or oil reforming, and we use it for desulfurization, hydrotreating, hydrocracking, heavier components of bringing into some useful products like petrol and diesel. So refineries consume a lot of hydrogen. We know how to produce hydrogen, how to handle hydrogen. And as far as the hydrogen as a fuel is concerned, or as a feedstock for various industries is concerned, nobody took it seriously. About 10-12 years back, when I was heading the R&D wing as director on the board of Indian Oil Corporation, I wanted to start the hydrogen activities, and in fact we had set up the country's first hydrogen dispensing station. We started blending it with natural gas, but nobody took us seriously. People said it is too far. But I told myself and my colleagues on the board that as Director R&D, my duty is to position the organization for future. And I had a vision that hydrogen is the ultimate fuel. Because when you look at hydrogen, this is carbon free. When we are not talking about net zero, and then, if you see the history also, we have moved from wood to coal and coal to oil and oil to natural gas and natural gas. Now we are talking about hydrogen. In fact, if you look at the chemistry of these products, you are reducing the carbon content in the fuel, right from wood to natural gas. The natural gas has only one carbon atom. So ultimately, we have to move towards hydrogen so that we don't emit any carbon emissions into the atmosphere, which is causing global warming. Now, when it comes to producing hydrogen in the refineries or elsewhere from fossil sources, we can do it from coal also. Incidentally, I headed a committee on coal to hydrogen, but there is a lot of CO2 emissions also. So CO2 has to be captured and either sequestrated through the various technologies which are available, or it has to be converted into some useful chemicals. And we have started talking about circular economy. Having said that, but if you can produce hydrogen from renewables, it's green. Hydrogen per se doesn't have a color. We have been giving it the grey, brown, blue and so on and so forth. But hydrogen produced from renewable sources like solar and wind you don't have to worry about carbon emissions or carbon capture, etc. So everybody has started talking about it. Being now the president of the Hydrogen Association of India, I say that I support all forms of hydrogen. One thing is because if we keep on waiting for the green hydrogen to become economical, I think we'll be delaying the creation of infrastructure and creation of the demand centers for hydrogen. So I have been propagating that let's start using hydrogen, move towards hydrogen economy as fast as possible, irrespective of the color. Eventually we will be going to green, but the path to green will have to be through blue perhaps. So that's my view on hydrogen. And I think that's the fuel of the, not of the future. Now the time has come that we have to start using hydrogen in all sectors.
Fair enough. Thanks, Dr. Malhotra. Maybe a follow-up to that question is, To have a proper green hydrogen, or for that matter a hydrogen economy, you need three factors. One, the country must produce enough renewable energy to manufacture hydrogen. Or second is to invest in hydrogen infrastructure, be it electrolyzer, fuel cells, storage, transport. And thirdly, the financing part of it. So maybe my next question would be to Gautam from Greenko. See, to manufacture green hydrogen. Or would you like to subscribe to what Dr. Malhotra said, where it did not be green hydrogen all along, it could be a transition?
I think, yeah, I don't know if it's working. So yes, it is indeed going to be a challenge to get enough green power, especially because the power industry itself needs power, right? All the utilities, industries, as part of deep decarbonization, if you actually look at the spectrum of energy consumption in India, almost 80 gigawatts of power are consumed by industries where power is produced through captive coal, and they are the most carbon emitting, whether aluminium, steel, iron, whatever you call it, right? So there's a lot of demand from that side as well. They are under pressure to decarbonize. So availability of power is not going to be a cakewalk, right? But it's not something that's not doable. I think the government is very cognizant of this. It's in that thought process that they are encouraging local solar panel manufacturing. Wind turbines are anyway manufactured in India, so there needs to be a big manufacturing revolution within the country so that we can deliver the power that is needed not only for the power consumption industry but also for upcoming green hydrogen. So, right, electrolyzers, fine, it's new, it's coming, but it'll happen. I mean, India has very strong animal instincts, if I can call it. Once the business comes in, people do come in, and there also this time I think the government is very clear that they would not let what happened to us with solar panels happen again once more to the nation. They are encouraging local manufacturing of electrolyzers and fuel cells in a big manner. So there are challenges like these, which again, like I say, is they're not insurmountable. What was the last part that you said?
Will the transition has to happen directly to green hydrogen or via?
So yeah, I think taking any extreme positions with regards to energy is never a good thing, especially a guy like me who's worked 20 years in oil and gas. I understand the length and breadth of that industry across the globe. I know prices are very high today, but that industry tends to go exactly opposite of where everyone says it's going, always. So when the prices are going high, they do come back, and when they do go back. But that's not the issue there. I think they provide huge amounts of energy to the world. While we are decarbonizing, the energy needs of a large, I think there's 40% of the global population still lives in poverty, 10% in extreme poverty, right? So we have to keep that in mind. So rapid overnight transitions don't happen. So in that context, I think there is a space for blue hydrogen as well. But again, that is a very regional divide in that requirement. For example, in US, where gas is at $8 today, I've never seen Henry Hub at 8 in my life, but typically Henry Hub has been $3-4. At that price for them to provide cheap energy for their own sources, blue will make a lot of sense. Now, coming to India specifically, I think we need to move to green hydrogen much more rapidly, because in India, even at the worst times, our imported gas price has never been below $10 or $11. Right? If you see the average gas price over the last decade, now at that levels of pricing, for us to transit to green energy, there's a lot more economic incentive other than a decarbonization. So blue definitely is needed, right? And it will happen in different regions of the world differently. So there's no one solution. You can't paint everything with the same brush. you'll have to use horses for courses kind of an approach in this.
No, I think I've overheard what you said, but maybe I'll ask Shardul as well, who had a bit of experience in renewable energy space, to see if he echoes your thoughts or he has a different view.
Amit talked about two reasons why we should consider green hydrogen. He talked about decarbonization and he talked about fuel security, energy security. I will add one more dimension to that security angle, is the food security. And I'll give you an example. Typical ammonia production requires around 35 MMBTU of the gas. Currently, landed price of natural gas is hovering for Indian entities between $18 to $22 per MMBTU, which used to be $10, as my friend said earlier in the past. So, if we look at the prices of the ammonia, which used to hover around $400 per MMBTU, has touched $800 per MMBTU. And for an agrarian economy like India, it makes immense sense to go for green hydrogen for a food security as well. Another small point on the renewable energy, what you said, which is a very valid point. Why hydrogen has become a business disruption, and it's simply because I require somewhere around 55 units of electricity to produce 1 ton of the hydrogen, 1 kg of the hydrogen. Earlier, if you do simple math, 55 units multiplied by 5 rupees, 6 rupees, which is a traditional cost, it used to be somewhere around 300 rupees per kg of the hydrogen cost. With renewable energy, my prices, I can stand up and say that over the next 25 years, my price is going to be between 2.5 to 3 rupees, levelized basis, if I do my financial engineering right. No other power source would be able to get that certainty of the prices, which is a very important for me when I'm as a user industry. I'll be more talking about user industry part, is that certainty of the pricing of green hydrogen, if we use through renewable energy, is far superior than as compared to the, let's say, blue hydrogen. That is a point I would like to make.
Next question would be to Deepak on, again on supply side, but more so on manufacturing. So one point that Shardul said is we would need 50 to 55 units of electricity, and therefore you end up even discounting open access charges, you are at probably 110, making probably about $2. But again, what you're also looking at is transport of hydrogen, which is again another pain. Maybe I'll ask Ashwini to comment on. But back to that question on electrolyzers, how is India faring on manufacturing of electrolyzers? One, and second, do you see that 50 to 55 units of electricity becomes a standard, or will that reduce going forward, bringing in efficiencies in electrolyzer operations?
Thank you, Mr. Reddy. And in certain cases, it can go till 80-85 gigawatt. And I'm not even talking about renewable. That is 100-150 gigawatt. So that is the magnitude of manufacturing that you are looking at, right? So let's say hypothetically, if the mission starts in 2024, and by 2030 we have to reach 5 million tons, and we are looking at least 7 gigawatt per year of electrolyzer manufacturing facility, which is needed in India. Right, and in terms of investments, numbers differ, but based on my interaction with industry, we need about like 400-500 crores per gigawatt. That is the number I know. Greenko can give you the right number perhaps.
How much is the global capacity today?
Also, global capacity, to my knowledge, is about 3.5 gigawatt manufacturing. That's it. So that is the manufacturing capacity that we need. And when we talk about electrolyzer types, there is a significant conversation which is happening, what should we do? Should we go for alkaline? Should we go for PEM electrolyzers? And when you talk to the manufacturers of PEM electrolyzers, for example, they say 85%, 90% of the components are being manufactured in India, right? But you can't equate a nut and bolt with a catalyst coated membrane, for example. So what is needed is not the domestic indigenization in terms of number of components, but indigenization in terms of the economic value add which is happening in India. And as of now, there is no mechanism to measure what is the economic value add which will happen by domestic manufacturing of electrolyzers. So that is one aspect that we need to take care of. Also in terms of PEM and alkaline, I think experts from Greenko etc. they can shed more light. But what people are telling us is alkaline electrolyzers today landed cost from China, for example, they are saying $350 per kilowatt. The manufacturing cost also they are saying in India it's about $350 per kilowatt. And so that is a significant improvement over what $1,000 per kilowatt that we were looking at. Secondly, I think you talked in terms of efficiency. So typically alkaline and PEM electrolyzers, they consume about 50 to 55 kilowatt hour per kg, and this corresponds to an efficiency of about 60 to 65%, right? But what can happen is with technology improvement, the efficiency can go up to 75-80%, which means you are looking at a specific power consumption of about 42 to 44 kilowatt hour per kg of hydrogen. That is a bare minimum, that will happen. But let's not limit ourselves only to alkaline and PEM. How about solid oxide electrolyzers? Although there are questions about the ability of solid oxide electrolyzers to work with varying renewable energy because the TRL level is low. But solid oxide electrolyzers, they consume about 35 kilowatt hour per kg of hydrogen. You also have to account for the thermal energy which is needed, but that is a significant jump. So when we are looking at electrolyzer manufacturing, we should not just get stuck with one particular type of electrolyzer, but look at the entire basket. Yeah, so I think in terms of electrolyzer manufacturing, two things: investment, first movers. And another very important point is about exports of electrolyzers. So today, countries across the world, they have committed to green hydrogen consumption target of 40 million tons. And this includes European Union, which is talking about 10 million tons of production and 10 million tons of imports from various countries.
And to put things in perspective, global hydrogen consumption today is what?
So today I think it's about 80 to 90 million tons, right?
It's like 50% jump in the next.
And this is by 2030, right? So if you do a rough math, let's say, we are looking at 8 gigawatt of electrolyzer capacity requirement per MTPA, then the total electrolyzer demand now is about 300 gigawatt at least. That's what we are looking at for a PLF of around 75%. And in a net zero compatible scenario, let's say global net zero, the total electrolyzer demand is expected to be 850 gigawatts. So so that is the market which the world offers to us, and therefore if we can be the first mover here, we can become not only a consumer of electrolyzers for us, but we can also become a global exporters.
No, I think before we jump into the storage, etc., storage and transport, a question to Gautam. And how are you indigenizing, and what's your plan with
alkaline, SOEC? You can debate all night, but again, I believe every technology has a place, and every technology has a architecture in which it can work the most cost effectively. So based on the round-the-clock power that Greenko is building assets across India today, we felt that with that kind of ability to deliver round-the-clock green power through our pump storage projects, we were looking for the most suitable electrolyzer, which obviously was alkaline in that case, because it works the best. It's a very reliable 50-year-old technology. I think a lot of you here would not have heard about this, but the first ammonia made in India was made through electrolyzers. In 1950s in Bakranangal Dam, when they constructed, they actually put a 1 megawatt electrolyzer there back in those days, produced hydrogen and made ammonia there. So and then of course when oil and gas started and gas became so cheap, it didn't make sense to continue with that technology, right? They didn't have too many decarbonization concerns at that point of time. So again, so at least in our architecture, we saw great value with alkaline. So we went across to John Cockerell. They were the largest alkaline electrolyzer manufacturers in the world actually today. Largest suppliers. They have more than 40% market share in China and 35% across the globe. So it was a natural fit for us. So we approached them, and they saw strength in our ability to generate renewable electricity. So it was a very fit partnership, complementary skills. So we've signed up with them to set up a joint venture in India. We'll be setting up 2 gigawatts of electrolyzer manufacturing capacity in the country, 2 into 1 gigawatt lines. Of course, pending all the land acquisition and environmental clearances, we hope to start delivering for the Indian market at least a gigawatt by capacity by end of next year, and then another gigawatt after that. So, yeah.
Oh, that's sweet news. So maybe moving on from electrolyzer to storage and transport, Ashwini, how do you think Indian companies are likely to cope up with this challenge?
What we are talking about is a green economy. For the economy to be green, there has to be several different aspects that need to be considered. For example, we've been talking about PEM electrolyzers, alkaline, etc. But we need to also talk about what India has an advantage of, which is biomass. So we have a lot of biomass which is available almost at negligible cost. And biomass is also another feedstock that can be used to create green hydrogen. Now, hydrogen coming from biomass will also be green hydrogen without the use of electrolyzers and other technology. Secondly, what we need to understand is where will this hydrogen, should the supply be focused on initially or the demand? Now, it is my opinion.
I'll come to the second part, demand, that's in the next half an hour.
Just a second. So my opinion is that we need to focus more on creating demand. And by creating demand, we can do that in a very simple format. Let's say compulsory mixing, for example, in what happened in petrol and diesel, mixing of ethanol with petrol was made compulsory. Similarly, mixing of hydrogen can be made compulsory for use in CNG, maybe at a smaller percentage initially. Then comes a very important aspect of finance. Now, finance, I understand an investment would be very difficult for companies to fathom whether such a technology will come into play or not. But why not look at something called CSR? Every big company currently has a lot of CSR that they are spending on social causes. A part of that CSR should also be attributed if any company uses green hydrogen in any manner. For example, the transport of their goods, the generation of backup electricity, or any other way of using
Ashwini,
green hydrogen.
maybe I need to interject here. The same idea was mooted to promote renewable energy 12 to 15 years back. And now you see renewable energy that is being developed has grown without CSR in place. Because there were hurdles in how CSR can be tracked, invested, etc. And hence, that route was not taken up, but nonetheless, we have a success in renewable energy.
Correct. Absolutely. We have a successful renewable energy program without without getting into CSR. But, for example, RPOs. The new policy says that renewable purchase obligations would be waived off for those companies manufacturing green hydrogen. Now, if they are manufacturing green hydrogen, in any case, they will be using RPOs. So, RPO will not really make sense for them, rather than if they could be...
One interpretation of that is it's for the entity which manufactures, not necessarily the SPV. So if there's a group company, it gets escalated
Even
to the
the
parent.
discoms get that RPO.
Yeah, second, if your discoms are supplying, yeah.
Absolutely. Absolutely. So what we need to understand is that the potential for use of hydrogen is immense. Right now, we are not transitioning to hydrogen in a manner where Dr. Malhotra rightly said, we cannot simply look at green hydrogen. What we need to also look at is every other form of hydrogen, because we need to not just transition to the fuel, we need to add another source. India is one of the lowest per capita consumers of energy in the world. We are less than the global benchmark also. And we are the fastest growing consumer of electricity as a whole, or of energy as a whole. So here what we see is that hydrogen will form an additional source for energy rather than replace the energy that we are already consuming.
No, thanks for the thoughts. No, Debi, I'll come back to the demand center before. I have one final question for Debi. Sorry, Debi, to keep you waiting. Especially with regards to manufacturing of infrastructure. If you can join those two, it will be helpful.
So main important is green hydrogen. Hydrogen is not a new thing in India. The reason is just the electrolysis or how you are fueling this electrolysis path, that is now changing. So for the because for hydrogen part, you don't worry about the demand side. Already the market is there for cement, steel and everything. So how you are doing the electrolysis using renewable energy, that's important. And why that is coming to the market, the point is now government is shifting the target from 175 to 500. And it is difficult to actually penetrate this 500 gigawatt of RE to the grid. So government is indirectly creating a demand for RE for the green hydrogen electrolysis. But the bottleneck is there, the cost of electrolysis is still high. It need to reduce. I don't believe have an ambitious talk about $1 per kg. If that is achieved, that is very good. Similar talk was happened in other industry also. But that need to be lower down. Otherwise now per unit, how you are using hydrogen maybe directly to the commercial or you are using in electricity, the per unit cost in India is more than 30 to 35 rupees. That need to be 4 times or 3 times to be reduced. Like from 35 rupees per unit from green hydrogen, it need to be reduced to 5 to 7 rupees. Minimum for the, comparing with for the industrial or commercial tariff. That is the first low hanging fruit for the industries to use. Then maybe we can go for the mobility applications and other applications. So that is one bottleneck first. Second is transportation and containerized. Because and we expect like only because this policy which has came out, it is only on the demand side. Like what happened in the solar industry or other industry, just pushing the demand, it will never happen. We have to focus as a country or as a state also on the manufacturing side. We expect now DHI or Niti Aayog should come out with a PLI scheme or some schemes for the electrolyzer manufacturing. Currently all the companies who are putting their foot forward is more on bigger announcement for futuristic manufacturing or maybe implementation of projects. So this is appropriate time for a PLI scheme for the electrolyzer manufacturing where the companies should enter at this point of time. Otherwise next 10 years will only on the large scale green hydrogen project, not on the manufacturing side. So this is the IESA's view, and the reason is why we are pushing this, because the demand is already there.
No, thanks for bringing the demand element. Before I get into the demand part, one final question to Dr. Malhotra. Sir, how do you see the government should step in from a policy perspective to improve the supply side part of it? Not the demand, only the supply side part of it. Are there any ways that the government can intervene? For instance, better IP transfer from global companies or funding facilities or by bilateral agreements with, say, Europe, for instance, for technology transfer.
If you're talking about not the demand side, only the production side. The production side of green hydrogen, as was said by my colleague here, that the biomass is one area where we all see a lot of pollution being caused by burning of the waste, biomass waste in the country, which causes pollution also, and that goes waste. Now, if all that, there are issues of collection of biomass and so on and so forth, but that's the cheapest source of getting hydrogen. As far as the government is concerned about green hydrogen, they have already come out with one policy, document, which I believe the second part of it is already with the cabinet and it will also be out soon. The PLI scheme for electrolyzers or other encouragements or some kind of credits for, as was said, that renewable, what you said about RPOs, etc. I think those are these things which government would be doing. But there is a limit up to which government can financially support. Because I tell you, a point was mentioned that the hydrogen, green hydrogen is cheaper than natural gas. I can tell you we recently did an exercise and Center for High Technology under the Ministry of Petroleum worked out. And we were preparing a report for coal to hydrogen options also, even with CCUS. And we found that the cheapest source of hydrogen is when you get it from coal gasification. The only issue with that is the CO2 emissions. CO2 emissions. You can always produce it from coal also, because if we are moving power side to the green power, India has large reserves of coal. You know, we are talking about supporting farmers, food security, but we have to also see affordability. You know, the biggest issue in this country is about the affordability of energy. Now, in whatever form you provide energy to our industry, the affordability is the biggest issue. Otherwise, your GDP will come down and overall economic growth will come down. So I am saying that hydrogen, ultimately we have to move to green hydrogen. But the path has to be through blue hydrogen. Green hydrogen has to piggyback on blue hydrogen. You know, Mr. Ambani has said that $1 per kg, although what he has said, I believe, because he does what he says. But if the power cost, as our friend was saying, about 3 rupees per and 50 is required, and somebody said 40 units will be minimum required even with improved efficiencies, etc., that comes to 120 rupees. The power itself. Then other costs, electrolyzer cost, infrastructure cost, etc., it cannot be cheaper than $3 to $4 a kg. And today you get, if you gasify coal, and even if you integrate CCUS, you can get hydrogen at $2 per kg. When you are talking about natural gas, we work in the industry, $12 per MMBTU of natural gas gives you hydrogen at $1.5 a kg. Maximum $2. So we have to see affordability also. I wish and I support green hydrogen, but I say that if we have to wait for the cost of green hydrogen to become affordable, otherwise industry will be reluctant. You can ask refineries to forcibly, public sector refineries to use 10%. You can say fertilizer industry in the public sector must use green hydrogen as an obligation, But the private sector will not use it. And the another important sector which we have been forgetting is about the transport sector. Sorry, you said I should talk only about production, but I am coming to the demand side. But important is the transport sector, where fuel cell developments need to be encouraged. Because the fuel cell can give you efficiencies almost twice of what the internal combustion engines give. Now, if you have an internal combustion engine today working at 25 to 30% of efficiency, and you can use fuel cell which can give you about 60% of efficiency, simple arithmetic calculation says our transport sector energy demand will come down by 50%. Now, if your overall energy consumption in the country comes down, the country saves a lot of money. Your import bills will come down, your energy will become maybe affordable. Only thing is that fuel cell developments also have to take place. So I think country needs to work on multiple facets. It needs to, on one side, work on reducing the cost of electrolyzers. Renewable power cost has already come down. There is little scope to reduce that further. But electrolyzers efficiency, because I am a researcher myself, I believe new developments will happen over the PAM or SOEC fuel cells, etc., besides alkaline, and you will get electrolyzers of high efficiency at a lower cost in this country. So that's welcome. And then the hydrogen cost will come down. Only thing is, let us, be pushing all forms of hydrogen. That will accelerate the infrastructure creation. My word of caution to the blind supporters, I will say, for green hydrogen would be that if you keep on saying, no, we should not use blue hydrogen, we should not use any form of hydrogen other than green, then I am sorry, that country will wait for the creation of infrastructure, because the cost of transportation, supply, delivery, once you will be ready, the infrastructure will not be ready. So if you have to see that by the time you are able to provide affordable green energy, green hydrogen, the infrastructure is in place, I think we need to move forward with all forms of hydrogen. So that's what I would say.
Thanks for your strong views, Dr. Malhotra. I think it's typical of any infrastructure. Does infrastructure drive demand or demand drives infrastructure? This is always a question. And on the staying on the same demand subject, my next question is to Deepak. Which segments do you think will be serviced by 4 segments? No, transport is one, buildings is another, power is third, and obviously industry as a feedstock. Where do you see that?
So, in terms of priority, I think the government has already talked about it. So, the first priority is refineries and fertilizers. And also we consume, about 0.1 million tons in petrochemical units, primarily for producing methanol. So I think that is the first priority that will happen. Now, in terms of other options, right? So in case of mobility, for example, let's say, we want to reach where US is today or South Korea is there, right? So even by 2030, we are looking at just 0.15 million tons of, green hydrogen consumption. And there also we have to be very mindful that, hydrogen is competing with batteries, for example, right? So passenger mobility section out, right? So we are only looking at hydrogen for heavy duty, long range vehicles, buses and trucks, etc. Now,
probably shipping or aviation.
Yes, I am coming to that, yes. So in terms of aviation fuel, for example, and this is where biomass is a very good candidate. So, we can produce sustainable aviation fuels by using biomass, where it is cheaper than actually using electrolytic hydrogen. And then if there are global mandates on blending of sustainable aviation fuel, the current mandate allows up to 50% blending, right? So if there are blending mandates, and sustainable aviation fuel is perhaps the next target. In shipping applications, there is just one pilot in Scandinavia, but when we talk to people in the industry, they are saying pilots by around 26, 27, and perhaps large scale commercialization. If dual fuel engines are actually developed, then we are looking post 2030. The last industrial sector, which is very interesting, is steel making. And steel making roughly, and so we produce like 110 million tons of steel. And if the entire steam volume to be produced using hydrogen, we are looking at in excess of 250 gigawatts of solar power installation. So that, green hydrogen for steel making, yes, but after all these applications, and we have done our assessment, we have released a report also. So if green hydrogen price is around $1.3 to $1.6 per kg, then your green hydrogen based steel making is actually breaking even with the current blast furnace technology. So I think it has to be sequence which are unlocked incrementally over the years, and we should not be aiming for all applications at one go. It's very important that we remember from the failures of early 2000s where we target hydrogen for mobility, and we had hydrogen highways, etc. in the US, in California. etc. Right? So it's very important to have those sequential unlocking of hydrogen as the prices reduce.
No, thanks. One final point here again, Deepak. Where do you see distributed utilization of hydrogen? Say, for instance, buildings or telecom towers. By the way, this is where most of the pollution happens, and secondly, this is where electricity is not able to penetrate. Hard to abate, in other words.
So again, in case of buildings, at least for India, I don't think hydrogen will. We don't need heating. We need cooling.
Concrete and steel.
Concrete. Yeah. Oh, okay. So in case of cement making, do you imply cement making?
Yeah.
No, I don't think. So there are estimates that green hydrogen can be blended up to 30% in cement kilns, but it's very expensive. Green hydrogen at $3.5 per kg is what? $30 per MMBTU, right? So in cement industry, I think biomass, waste, etc. are the best options. So you talked about building. You talked about what was the other industry?
DG sets or
that is a very promising application, but I think Dr. Malhotra very aptly put that supply chain infrastructure for telecom towers, I think that is the key bottleneck there.
Thanks for that. So my next question to Shardul on financing part. Both on the demand side, on the supply side, you would need significant financing to be committed. Where do you see that coming from?
That's a fantastic question, $1 billion question, which is right now we are also struggling with. So what I envisage is that the initial wave of few pilots will have to be funded out of equity. There is no question on that. Okay, even Macquarie has committed, so those we will run through with this one. When I talk to my industry colleagues in the development financial institutions, their eyes and ears, they have slightly opened up. They are asking to me is that demand side, are we too early to lend at 10 crore per megawatt of the electrolyzer capacity? So that is a very valid question. Is why we should lend when we know prices of the electrolyzer are bound to come down. So I said that's a very valid point. So my guess out here is like we had case of a solar, even at when we had the long-term arrangement for offtake, that's where the financing of the solar projects became slightly amenable. If you remember 2000s and 2005s, similar case would happen even if we strike contracts at, let's say, 400 rupees per SCM.
Tough to do the math, but I think,
300, 400 rupees per SCM.
At least what you're saying is, there is doors opening, there are doors opening, and then there are avenues to tap.
Right. So, and I'm telling you, on the landed basis, the cost of the hydrogen is, let's say, coming to somewhere around 35-40 rupees per SCM currently. If you do divided it by 0.883, it comes to around 400 rupees of the landed basis, the prices of the hydrogen, and one has to do reverse maths to fit anything between 350 to 400 to arrive at the ultimate pricing. So it's going to be a, I would say, blocks. I need to put blocks, right perspective, probably first the equity and then probably the debt which is coming from development financial institutions.
Yeah. No, thanks for that insight, Shardul. So next question to Debi, Prasad and Ashwini as well. I think you have had strong views that FCEV should be considered as part of EVs. So maybe you can enumerate on that.
Okay. So just considering in the power sector scenario, hydrogen maybe take another 5 years for adoption in India, because across the globe it is happening. Majorly, the first is infrastructure and commercial industrial applications, which will, because they are directly using now hydrogen. If you are changing the generation from blue or grey hydrogen to green hydrogen, that will be the first one. But the issue is now cost. That's the first part. On the grid side, hydrogen, yes, it can work as a storage, but it failed. Earlier, it has tried in telecom infrastructure in India 10 years back. The companies are not in India yet. It was Intelligent Energy, Essential Energy. They tried to put 3 kilowatt, 7 kilowatt, 10 kilowatt systems in 2013-14. But the cost was too high, and the electrolysis to the remote telecom tower, the transportation cost was also high. So to replace the energy storage systems, because now as the gigafactories are evolving, now the planned gigafactory is 600 gigawatt hour in lithium-ion space. So you can see the investment in lithium-ion gigafactories across the globe. Automation is happening. So the price fall, how it is happening in lithium-ion, green hydrogen may not compete in the power industry in next 5-6 years. That's the first thing. Because it is not our choice. It's about how the industry is investing. So now if you want to convince the investor to invest in, with all due respect to other chemistries, sodium ion, flow batteries, aluminum and others, the investors are not ready. The investment is not happening. Automation is not happening. Now 80% patents in electrochemical batteries is coming in lithium ion. 80% patents.
Sorry.
So you can see how the...
Back to my question. So you see hydrogen playing a role in electricity
grid? Hydrogen will
grid?
play a role in grid, but maybe after 4 or 5 years, not at the current scenario.
Before I go to your question about FCEVs, I would only like to make a small notation about what Mr. Das just said. The price of green hydrogen or hydrogen today might be very high, and it may seem that lithium ion is the way to go forward. But we have to realize that lithium, currently electric vehicles are the primary consumers of lithium ion batteries and other forms of lithium ion storage. But electric vehicles constitute less than 2% of the global EVs. and global vehicles altogether. And the demand for lithium, the moment it exceeds a particular benchmark, the prices will skyrocket it is already skyrocketing, yes, but it will skyrocket to such an extent that obtaining lithium will become very difficult. For a country like ours, which is already dependent on oil from different countries, tomorrow we will become dependent on lithium, and not to other countries where lithium is produced, for example Chile and Argentina, but China, because China is controlling all the lithium, almost 80% of the lithium assets of the world. So how do we compete with our neighbor, our hostile neighbor, mind you, with a product that we are expecting that we will change our economy and make it greener? Coming to the second part of your question about FCEVs. So I was part of the drafting committee of the Haryana electric vehicle policy, and we were able to incorporate in that draft a small provision for hydrogen. Now, it has been my efforts to even include hydrogen EVs under the FAME Act, and for that there was a order by the Delhi High Court in a writ petition which it said that the DHI should consider whether FCEVs can also be considered as electric vehicles. However, the matter is pending, that's a separate issue. But what I would want to say is, hydrogen is going to be the only other form of energy which can be transported beyond geopolitical, situations. For example, if we go in completely electricity, we cannot transport electricity to countries which are unable to create.
So Ashwini, my next question, actually my first question to you was on that, on the transport. How do you see hydrogen getting transported, given that it has a high volume requirement, or you need to pressurize it, or you need to liquefy it, or you need to convert into ammonia?
Correct. So hydrogen actually has three big challenges. Production is one, then the transport, conversion, reconversion, efficiency, the loss of efficiency is second, but the third part is that it is easily transportable. It is the fuel which can be, for example, let's say the Russian-Ukraine war that is currently happening. This has created a huge pressure on the global oil supply chains, and this is what may happen in future between other countries. What if tomorrow there is a Gulf war or something like that? Then what will happen to the oil prices? At that time, we cannot expect to transfer, solar energy from one country to the other, or maybe beyond a particular, geopolitical arena. Because that way, we find that geopolitics comes into play. Like the Russian pipelines have right now become controlled by Ukraine. They are trying to, exactly.
The drift of it, it has a geopolitical ramifications.
Yes,
as
but
well.
like oil, hydrogen can actually be transported from India all the way to Korea, India all the way to Europe. It can go to Germany. जैसे oil होता है वैसे the same way hydrogen can be transported, and that is the only way India will become an energy player rather than an energy buyer, because hydrogen is the only way forward for India to become a dominating force when we want to be a global superpower.
No, I think I get the passion from you, and why you are fighting FCEV to be included in FAME2 scheme. But maybe on my last question on the usage cases is to Gautam. While you have views on how to manufacture, and you have thankfully explained your plans, but where do you see the hydrogen that your electrolyzers, the electrolyzers that you manufacture will manufacture, be used?
Patients, I think it will happen. If you, again, the risk of repeating, I think there's a very immediate requirement in areas like refineries and fertilizers especially. Ammonia is even touching $1,200 per ton actually, right? We were in Europe last week in this International Fertilizer Association meeting. The whole meeting was about, very interesting actually, Fertilizer Association discussing decarbonization for all day, right? And they were also talking about how climate change is hurting crop yields. That's, there's a big problem there, right? So that was very interesting. So I think those areas, things will move very quickly. right? And again, we cannot, there's no, you cannot pigeonhole into, I mean, it will be very different in different parts of the world, right? Depending on the requirements of some countries, even mobility can probably happen, but at least in India, I don't see, I concur with most of the views here. Mobility will probably take a little more time. Eventually it will happen, right? But immediate usage is feedstock in India and a big export opportunity for India. I think that's a big, we cannot stop importing crude and all that, but if we can somehow convert hydrogen into green ammonia or green methanol, products like these and export, we can reduce the burden on our foreign exchange. So I think there was this very interesting report by McKinsey and a bunch of people. I think even IRENA released a report recently where they evaluated a bunch of factors, not just irradiation, because people talk a lot about North Africa being outstanding. But the problem is, if you have actually lived, and I've lived in Algeria, so I can tell you, first of all, to believe that you can invest money for 25 years in North Africa is a big problem, right? Yeah. So, there's very theoretical calculations about irradiation, wind and all is one thing. But based on all that, they said India has number 2, actually after Chile. They ranked India as number 2 after Chile to be able to create the most reliable hydrogen ecosystem, right? So I think that will enable us to export a lot of this out. I think that will happen. Yeah.
No, that's great and that's heartening to hear. No? And there ends my question here. And before we wind up, if any of the panel members want to share their views in a minute, yeah. By the way, once we are done, probably audience can ask the questions, or a 2-3 minute span, please.
Yeah. So I will add that India starts export of green ammonia, and in that process we learn and then optimize and then use that optimized experience for cost sensitive industries, number 1. Number 2, in the part which my fuel cell passionate speaker he talked about is the thanks to adventures of Mr. Putin, this discussion has become animated, and that is basically talking about the democratization of the energy access. And hydrogen in any form, Dr. Malhotra, your point, in any form would be actual democratization of that energy access. Hence, I support that.
Oh, thanks for your use. Ashwini, Devi Prasad, Dr. Malhotra, any final thoughts?
Kulkarni just said that hydrogen will democratize energy. Every country which today may not have reserves of oil or gas may start producing hydrogen, and that will give a kind of a sense of power to a lot of other nations to be able to sustain themselves in a period of conflict, especially countries in South America, countries in Africa, Asian countries, especially India. We need to be able to secure ourselves not just energy wise but also in a global scale. We need to be self-sufficient, and hydrogen is one of these few things that can make us totally Atmanirbhar.
One thing, last point which I thought just comes to mind is just to, again on the transport sector, EVs versus hydrogen fuel cell vehicles. The lithium prices, that was touched by someone. Lithium is a component which is used in grease manufacturing. Also, one of my friend is a grease manufacturer, and he told me that in last 6 months the lithium prices have gone up 5 times, and it is unaffordable for producing grease. I was reading a report where Tesla has said that they're cutting down on production of the battery supplies are not coming because of the high lithium prices. The other issue about the energy security for the country is that hydrogen is the way to go about, not the electric vehicles. My friend who said that he has been looking forward to government support for equivalent support for hydrogen fuel cell vehicles as to EVs is a very right approach, because hydrogen in any form, tomorrow when we have abundance of green hydrogen, we'll be able to run the hydrogen fuel cell vehicles based on our own. Lithium is controlled by China. Now today we are running our vehicles based on the fuel being imported from Saudi Arabia. Tomorrow you will be dependent on China for imports of lithium. So I personally think that it is safer for us to be dependent on Saudi Arabia or to Russia or to multiple sources of oil rather than being dependent on China.
I think while I like that thought, I also see Debi Prasad not accepting to on the lithium part. But again, Debi Prasad on hydrogen, not on lithium or batteries.
Only the policy will not drive the market. So regulations and regulating framework need to be developed in India, both on the manufacturing side and also on the adoption side. Then only maybe the price will fall and the adoption will increase.
No, valid points. Any questions from the audience? Or we are all available after the conference as well. You can ask us. No. Thanks panelists. No, thanks for this scintillating discussion. No, I did quite like.